Nowadays, we take for granted the fact that we can travel by car, bus, train, boat or plane, that we can turn on the heating when our homes are cold, and that with the flick of a switch, we can use electricity to run an amazing range of appliances, but our lives haven't always been so convenient. The energy that we use for transport, heating and electricity generation comes from a range of energy resources. The main types of energy resources which are used in the UK and around the world are as shown here. These can be split into two main categories, non-renewable and renewable energy resources, and we'll look at these in turn throughout the rest of this video. Coal, oil and gas are all fossil fuels. They're formed from the remains of plants and animals which died millions of years ago. Fossil fuels are non-renewable, which means that there's only so much coal, oil and gas available on the planet. When it's all been used up, there'll be no more left. Well, unless you're willing to wait around for a few million years for more to form. This graph shows roughly how much coal, oil and gas are left on the planet, but it's only an estimate, as the rate at which we use these fuels could change and new resources could be discovered. Because they're cheap and convenient, fossil fuels are very popular. As shown by this pie chart, most of our electricity in the UK is generated by the burning of fossil fuels. They're also used extensively in transport and heating. On the downside, they're pretty bad for the environment. When they're burnt, carbon dioxide is released, and most scientists agree that the burning of fossil fuels is a major contributor to global warming. For this reason, the UK government has committed itself to reducing carbon dioxide emissions to a fifth of their current levels by 2050. The burning of fossil fuels also leads to the release of sulfur dioxide, which can combine with water in the atmosphere to produce acid rain, which can kill plants and damage buildings, in addition to causing breathing problems in humans. For your exam, you won't be expected to remember this entire diagram, but it's kinda useful anyway, since it helps explain how the burning of coal, oil or gas is used in the generation of electricity, and it ties together a few different parts of the course quite nicely as well. The steam which is produced in the furnace is used to drive turbines. The rotation of these turbines in turn drives the generators that produce electricity. The generation of electricity in a nuclear power station isn't actually that different to this, except that instead of using a furnace, we use the energy released inside a nuclear reactor to heat the water or other fluid that drives the turbines. Nuclear power currently generates just over 20% of the electricity in the UK. The nuclear fuels which are used are called uranium and plutonium. Because nuclear fuel is mined from the ground, this is also a non-renewable energy resource, but we think we have enough of the stuff in the ground to last for thousands of years. Nuclear power stations don't release harmful polluting gases and so don't contribute to global warming, but the radioactive waste they produce has to be stored away carefully. There's also a small risk of a nuclear power station undergoing meltdown, a process which can release large amounts of dangerous radioactive material into the atmosphere and surrounding area. So far, we've covered the 4 non-renewable energy resources. Let's go on to the renewables now. A renewable energy resource is one which will never run out. Renewable energy resources are either replenished immediately or can be replenished quickly. Biomass means biological material. This comes mainly in the form of waste wood, but can take other forms too. When biofuels such as wood are burnt, the heat released is used to generate electricity on a small scale or to heat buildings directly. Although carbon dioxide is released when biofuels are burnt, plants absorb carbon dioxide from the atmosphere before being turned into biofuels. For this reason, biofuels are often described as being carbon neutral. Tides rise and fall twice a day. When they do so, huge amounts of water move in and out of river estuaries where rivers meet the sea. Tidal barriers are expensive to build, and so for now, only a relatively small amount of electricity is generated globally by tidal power. A tidal barrage is like a dam which is built across an estuary. When the tide comes in, large underwater gates are opened up to allow water through. These gates are then closed at high tide, storing water upstream from the barrage. When the tide goes out again, a different set of gates is opened to allow water to flow through and turn the turbines which are connected to the generators which produce electricity. In this way, although tidal power is expensive at first, the tides form a very reliable, renewable energy resource, as we know exactly when they'll rise and fall at a given location. Hydroelectric power stations also rely on the movement of water for the generation of electricity. In the most common form of hydroelectric power station, a dam is built across a river. This leads to the formation of a reservoir or lake upstream from the dam as shown. For this reason, many hydroelectric power schemes have had the following negative impacts. People have had to move from their homes, wildlife habitats have been destroyed, farmland has been lost, and forests have been cut down. On the plus side, hydroelectric power stations produce large amounts of electricity without releasing carbon dioxide into the atmosphere. Some hydroelectric power schemes use a technique known as pumped storage. When the demand for electricity is low, excess energy from other sources is used to drive the generators in reverse, which causes water to be pumped back up into the upper reservoir. In this way, this stored water, which acts as a store of gravitational potential energy, can be released back down through the turbines when the demand for electricity is higher. The power of moving water can also be harnessed on a smaller scale by various types of wave generators. Here's an example of one such generator. When a wave strikes this particular device, the air inside is compressed and is forced rapidly through this turbine, causing it to rotate, which in turn leads to the generation of electricity in the connected generator. As the water level inside the device falls, air is forced to rush back through the turbine in the opposite direction, which again leads to the generation of electricity. When the blades of a wind turbine rotate, they turn a generator which allows for the production of electricity. The higher the wind speed, the faster the blades will rotate, and so the greater the rate at which kinetic energy will be converted to electrical energy inside the generator. Wind power is renewable and clean. It's also unreliable though. If the wind speed is too low, a turbine will produce little to no electricity, and if it's too high, the blades will have to be fixed in position for safety reasons. Also, many people are unhappy about the visual impact that land and sea-based wind farms have on the environment. Having said all that, wind power does play a valuable role in meeting a country's electricity demands. When the wind does blow, the amount of electrical energy that must be supplied by fossil-fueled power stations decreases. In other words, the amount of fossil fuels being burnt decreases, which reduces greenhouse gas emissions. The sunlight that falls upon a solar cell is used directly for the generation of electricity. Although solar electricity generation is unreliable in some countries, it can still reduce the amount of electrical energy required from the burning of fossil fuels, no matter where it's used. In hot countries, sunlight can also be used directly for the heating of water for use in plumbing systems. Geothermal energy is both clean and renewable. Geothermal energy schemes involve the use of water or steam which is heated naturally by processes within the Earth's crust and below for the generation of electricity or the direct heating of buildings. Because the stored thermal energy within the Earth can only be accessed easily in certain places, however, generally wherever there's a lot of volcanic activity, geothermal energy is only used in a relatively small number of countries. That brings us to the end of this video on national and global energy resources. Thanks for watching and good luck.